This is assignment 7 for SEG 3103 regarding TTG, or for long, test-driven development. I'm Will.
I am Noah Stevens.
And I'm Aiden LaBelle.
Thank you. So, to begin, this will be our first slide, or technically second, because this is actually our first slide. But the first slide with content today is going to be our code walkthrough. And the code base we're using for this is a basic calc, which is short for calculator. And that's just slang. Whenever we say calc, we mean calculator.
Yeah, we'll be referring to calculator.
What can this calc do?
Some of the functions on this calc, which are addition or add, division or divide, subtraction or subtract, and multiplication or multiply.
Well said, Noah. I'll be introducing the problem. Well, we want to develop a simple calculator program, as was highlighted before, with the aforementioned functions that I've written down again. And we also want to be able to catch errors as well as edge cases. And we want to develop this using the TDD methodology. Next slide.
Now, what are the benefits of TDD, and what is the red-green refactor cycle, you may ask?
Yeah.
Well, the TDD is a 3-step cycle which aims to create good code early in development. So the first step, create a failing test before you write any code. Step 2, create code that passes the previously mentioned tests. And then step 3 is to refactor code to continuously pass new test cases. Now, what are the benefits, you have already asked? Well, the benefits include catching errors before it's too complex to solve, creating good code early, and thinking ahead of the problem before it starts to become the problem.
Splendid.
Well said, LaBelle. For our
Thank you.
first TDD test, I'll be looking at subtract. So the very first thing we want to do is create a failing test. Now, since we don't have the method subtract, this test fails automatically because the method doesn't exist, so it can't call it. Knowing that, we should get 5 if we do 10 minus 5, I wrote the code in such a way that would allow this test to pass. By doing the genius move of returning A, the first number, minus B, the second number. This will ensure that 10 minus 5 does, in fact, equal 5. Next slide.
This is our test 2 for TDD, or test-driven development. So as similar, we start with the test case, which is test division. So as you can probably guess, we're going to be testing division with this test case. So the first line of code returns the division from 10 and 2, which is 5. But because this divide function hasn't been written yet, it will initially be red, or a failing test case, in other words. So how do we make it green, or a passing test case? We do that by writing this function below. So we started with the problem, and from it, we solved it by writing the code divide, this function, which just returns A divided by B. Now the above test case can pass.
Now, similar to test division, we'll be looking at test multiplication,
Test subtract.
where we'll be attempting to multiply 3 times 4, which should be 12, but since the multiply function has not been written yet, it will fail initially. So we have decided to write multiply, which multiplies A times B, to make the test green and pass the test.
Beautiful. I also just want to say it might be unclear. When we say the test will fail, you might be confused because it's right here. But the test fails without this bottom function, which we add later. Initially, it's only this test function.
Because it succeeds when we add it, when we created
Exactly.
the passing test. Okay.
It turns green.
Yes.
It turns green.
We just put them both in here for context.
Now, we're going to catch a little edge case here. I guess not really an edge case, because you can't really divide by 0. So this one's going to be the division by 0. And, what happens if you try to divide by 0 in real life, Noah?
Nobody knows.
It's undefined. But in Java, it will throw an exception. In that case, an arithmetic exception. So we need to make sure that this test division by 0 assert that it throws this exception. However, if we run it without modifying the divide, or just we return double A over B, it will fail. In that case, we need to add an if statement. If B is equal to 0, the divisor, it's going to throw a new arithmetic exception with the message division by 0 is not allowed. This. Next slide.
So finally, our TDD test 5 is going to be addition with strings. So what this allows us to do is instead of just saying 2 plus 3 with numbers, we can say 2 TWO plus, which is going to be the same addition sign, and 3 THREE. So this opens up the functionality. But with the previous function, with the previous add function, without this parse int code, would fail. So whenever we run this test, and you assert that it throws an illegal argument exception, it won't work. But now, with this, you have...
Because of the catch. Because of the catch, right?
Because of the catch. Whenever you have the parsed to an integer from the string, you add it, and you have to make sure that it's valid input, which is what the test is making sure of.
Well said, Noah. These are all our test cases that passed. As you can see, they all passed with the code that we provided. As you can see, check mark, check mark, check mark, check mark, check mark.
5 full check marks.
That's an A+.
You might be thinking, how did TDD change the way we wrote our code? TDD, or test-driven development, forces a mindset shift to thinking about requirements and expected behaviors. It forces the user of test-driven development, so the writer of code, to break down problems into small testable parts, like we did with the input integer stuff, ultimately resulting in more modular and cleaner code. In effect, for this lab, it meant we focused on features when writing code, instead of sitting down and writing a big block of code all at once.
What challenges do we face during this lab? Well, we had to decide the right level of specificity for each test. We didn't want to be too general or too specific. We also had to resist the urge to write the implementation before writing tests. As you can imagine, writing test cases before implementing it seems unnatural because, there's a bunch of syntax errors, and when you run it, it actually won't be able to run because it won't be able to get the functions. We also had to think of the unexpected edge cases during later tests, such as sending over random strings instead of parsable integer strings. And then we also need to make sure that when we refactored, we didn't break previously passing tests. So in an instance with the addition one, originally we had a basic addition without the catch. And now we had to implement that catching part while making sure that it doesn't break the first half. As you can imagine, this might get a little more challenging with bigger code bases.
Well said. But there are some drawbacks to TDD. It's not all sunshine and rainbows over here. Initially, it will slow down development because instead of writing big blocks of code like many developers are used to, they'll have to break things up and write the test cases first. Secondly, it can be hard to apply with abstract understanding of needs. So say you want to make a system and you're not quite sure what you want it to do, you can't write a test case for something you don't know what you're testing. So it can be hard in that aspect. This can also lead to over-testing simple code. Because you write the test cases first, say you want to develop something, a feature per se, on the same program, that means you're going to be writing test cases about this feature. But because the features are on the same program, you'll be testing the same program 5 or 6 times at least, or maybe more with bigger systems.
Like multiplication.
Quite. There can also be a steep learning curve to understand how to get value from this system. Because of the initial learning curve, it can be tough to understand how to get value from the system.
Next slide. Thank you so much for listening to our presentation. I've been William, and thank you so much.
Thank you so much for listening. This really means a lot to us. Thank you. I've been Noah. Anything you'd like to add in? Oh.
All right. See you next time, TA.